Before we start here, let's just make sure. Yeah, write these down here. Again, these things we're writing down: the square root of 2, the square root of 3, the square root of 5, and the square root of 10. These, ladies and gentlemen, are what we call irrational numbers. They're irrational. They don't make sense, but the simple fact is they don't ever work out. They are decimals that never end and never repeat. If a decimal repeats, it can be changed to a fraction. Okay, if it never repeats and it doesn't end, it's irrational. We can only get what we call approximations, which are what this little squiggly equal sign is. If you see that, it means it's close, but it's not exactly what it would be. And most of the time when we talk with irrational numbers, we have to be satisfied with close. And these are the close numbers. The square root of 2, in other words, what number times what number gives you 2? 1.41 is as close as we're going to need to be. That's not exact, it's close. What times what gives me this 3? 1.73. What times what gives me 5? Well, you know it's got to be more than 2, but less than 3. It's 2.24. And what times what gives me 10? You know it's got to be bigger than 3, but less than 4. What is it? 3.16. 3.16. These are not exact numbers again, they are what we call approximations. Because you will get answers that involve these things, and you need to know, I mean, at some point in your life, if you ever deal with square roots, you're going to need to know what's close enough. People that build buildings and end up with square roots and stuff, they need to know how close or what to cut or what to measure. So if I had this, if I had 10 times the square root of 2, you should be able to tell me right now, what would that be close to? 10 times the square root of 2 is 10 times that thing there. I'm going to check which is close to, what would be this times 10? Yeah, 14.1. But again, that's close to, but not exactly. Or if I had 8 times the square root of 10. Well, since I know that the square root of 10 is 3.16, 8 times the square root of 10 would be close to probably, just give me something to guess, Alex. 25. Yeah, probably close to 25. And again, most of the time getting close is going to be good enough. Now, if we were sending the space shuttle or something to the moon, we probably want to be a little bit more accurate than just that, but right now that's good enough. That really doesn't have anything to do with what we're doing today, but I just wanted to see that. It really does, but I'm just kidding. Now, there are times when you can simplify square roots, and here are the steps to that. For example, if you see the square root of 20, that can be simplified. You can make it easier to understand. And your first step in that is you need to prime factorize it. Our good old buddy prime factorization. And when you do that, it looks a little like this. The square root of 20 breaks down into, and you need to write these square roots down. Don't start being lazy or whatever. It's the square root of 2 times the square root of 10. This one is prime, so you can stop. The square root of 10 breaks down into the square root of 2 times the square root of 5. And that is the prime factorization of that. Stop. You can catch on to that. I just prime factorize it like it was a normal number when I prime factorize. So I ended up with the square root of 2 times the square root of 2 times the square root of 5. Kendall.
Can we do the square root of 2 to the second power?
No. Don't do it because it's not going to really help you for what we're going to do here. Step number 2 is this. Caroline?
When you prime factorize those, do you have to use the square roots that don't equal anything? Like, you can't use like 4 and 6.
Well, your question might be answered, I'm not sure exactly what you're, but it might be answered a little bit later, so just hold off on that, I'll see. Okay, step number 2 is, any double square roots will cross off to give you a regular number. And I'll show you what I mean after you write that down. That simply means this. If you have two identical square root ones, you cross both of them off and just write one normal number that it was. And the reason for that is the square root of 2 times the square root of 2 is the square root of 4. And what is the square root of 4? 2. 5 doesn't have anything to cancel off with or whatever, so you have to then write it right next to it just like it is. The answer is 2 times the square root of 5. Step number 3 would be to, anything that's left, if you have to, you need to remultiply. Did I spell that right? Multiply, if needed. Now, some of you that are quick at math, this won't be everybody, but that's just God's gift to some people. You know, if you can look at this right off the bat and say the square root of 20 is the square root of 4 times the square root of 5, knowing that the square root of 4 is a perfect square, right off the bat you can say, okay, well I know the square root of 4 is 2, so bam, it's 2 times the square root of 5. Some of you won't catch that, but some of you have to just do it this way for now. It'll come a little bit later.
So what's the last step?
Remultiply.
Wait, couldn't you just multiply 2 by 2.24?
Yeah, but they didn't ask you to give the approximation, but this is the exact number, you need to give that exact number. But you should know that square root of 5 is 2 times, so that's close to 4 or whatever it is. How about this one? The square root of 48. It doesn't matter how you break it down, the square root of 48 is the square root of 6 times the square root of 8. The square root of 6 is the square root of 3 times the square root of 2. 8 is the square root of 2 times the square root of 4. And 4 is the square root of 2 times the square root of 2. So you end up with 4 square roots of 2 and the square root of 3. Stop me if you don't quite get how we got those square roots. Again, it's just prime factorization. That's not, we've been doing that since 6th grade, maybe even 5th grade. Now you look for doubles. You still got any misses.
There's
You got a set of 2 there, another set of 2's, and nothing for the square root of 3 to cross cancel, so it ends up staying there. And this is the point where I said you need to remultiply. If you end up with these 2 things, they get multiplied together, and it's 4 times the square root of 3. Four times the square root of 3. Charlie,
Where'd you get those 2 leftover 2s?
did I get to whose?
The 2 leftover 2s.
These 2?
Yeah.
2 square roots of 2, a double thing crosses off and gives you a normal 2. Just one normal. Another double thing crossed off and gave me a second normal 2. And I remultiply them, and I end up with 4 times the square root of 3. Taylor Page.
So will it will it always just be like a number and then a square root number? There won't be any.
Yes. No addition, no subtraction. Let's do this one. Square root of 90. Square root of 9 times the square root of 10. Square root of 9 is the square root of 3 times the square root of 3. Square root of 10 is the square root of 2 times the square root of 5. Again, double square roots of 3 give you just a normal 3. These two don't have their doubles, and just like if you got two regular numbers, you multiply them back together, same thing here. Two square roots that you end up that don't cancel out, they need to be re-multiplied so you get 3 times the square root of 10 as your answer. Okay, you end up with either the square roots or the things.
So all equal to numbers.
Generally, there will be one regular number times the square root of number. Unless something doesn't, unless you can't factor something down. For example, you have the square root of 30, that breaks down into the square root of 6 times the square root of 5, and the square root of 6 is the square root of 2 times the square root of 3. There are no doubles there. Nothing can cross off, nothing can be simplified. This is as simplified as we can get. Square root of 30 because there are no doubles or twos that break out. One last one. Square root of 1,000. Now, for those of you that maybe are catching on to this, I'm going to do this one way now, maybe do it the other way. Does anybody know what times what gives me 1,000?
100.
Times what?
100.
Okay. Here's something to think about. The square root of 100 times the square root of 10. Now, right now you can look at this and go, 100 is a perfect square. Okay? If you can think this way, you don't have to keep breaking this down because you know there is a square root of 100. You could right away cross that off and say, well, the square root of 100 is 10. Square root of 10 we know from before can't be broken down because we gave the approximation for it. That is the answer to it. Now, if you don't catch this, then go ahead and break it all the way down into, it would break down into the square root of 2 times the square root of 2 times the square root of 2 times the square root of 5 times the square root of 5 times the square root of 5. That's the prime factorization of it. These two would cross off and give you a normal 2. These two would cross off and give you a normal 5. You'll be left with the square root of 2 and the square root of 5. Remultiplying the normal numbers, you get 10. Remultiplying the square root numbers, you get 10. 10 times the square root of 10.
Yeah, I'm just waiting.
Again, know your limitations. If it only works with you breaking it all the way down to the end, then by golly, do it.
Oh!
If you can see, if you recognize this, like the square root of 50, look for perfect squares. The square root of 50 is the square root of 25 times the square root of 2. And there is a square root of 25, which is 5. So there it is, your answer, because you know the square root of 2 times 15.
Okay, I'm not.
Otherwise, you can break it down into whatever things there. Kendall.
Don't you have to break down into, or I mean 10?
Yeah, but I know the square root of 10 is going to break down into what? 2 and 5, and 2 and 5 aren't going to cross off with each other, so there's no point in breaking it down just to be multiplied again.
So we don't have to break down certain numbers?
Well, I would say specifically the ones that we did right here. If you see these can't be broken down. Those are as far as we're going to go. So you end up with a square root of 10, it's not going to break down anymore. Unless you get another square root of 10. Then it will. If you have 2 square roots of 10, it will. But in the end, if there's no other, these numbers aren't going to change.
So if you put square root of 2 and square root of 5, what
Well, you'd have to remultiply. If you get a square root of 2 and a square root of 5 left over, you have to multiply those together.
Oh, so the reason would be I did like multiply, or the square root of 2 and 5.
Right. When these two are left, I needed to remultiply those. Otherwise, it's not a simplified thing.